All right, great. Can you hear me?
All right, talk.
Hopefully you can hear me. Yeah. You let me know if I'm talking to myself here. So this is me watching you watch me. This is great. What a great turnout. You know, I have a radio club here in Northern California. It's nowhere near as sophisticated as what you guys have. So yeah, fantastic. Kudos. It really looks good here. So I'll minimize this. So to introduce myself, for those of you who don't already know me, my name is Craig Lamparter, amateur radio call sign KM6LYW. My day job is really a Linux systems software engineer. So I work with Linux every day, all the time. I work with the open source community, and I got into amateur radio a few years ago. And what I really found is that the open source community and the amateur radio community really have a lot in common. It's all about sharing and sharing alike and learning, advancing the state of the art. So I was thinking, man, we really got to get open source software and ham radio together. You know, a lot of people are already doing that, but we're going to see if we can take this to the next level. For some fun, I just started a YouTube channel just for something to do, and actually met so many cool people worldwide. You have no idea how big of a deal amateur radio is once you really put yourself out there, and you can really start making some interesting contacts. You know, a lot of amateur radio friends in Europe and Eastern Asia. It's not just here in America, it's Australia. So met a lot of really cool people starting the YouTube channel. So I think I actually get more out of that than I could ever possibly give out to the YouTube channel. So every YouTuber has like some sort of Patreon thing to help pay the bills. And as I decided, well, maybe I'll just make some software, and that way I'll have something tangible to give back to patrons of the channel. And that was something that we came up called DigiPi, which is an amateur radio data transceiver. It's an SD card image. So I have an SD card right there. You put it in a Raspberry Pi, you hook it up to a radio, and it basically turns your radio into a website. So all you need is a web browser to operate your radio. Every data mode you can think of. What's interesting about, I'm going to actually make myself smaller and show you this slide here. So what's interesting about this picture right here, this is at 2,500 meters. This is about 60 miles from my house here in California. This is about over 8,000 feet. And the only form of communication here is really amateur radio. And from where I was standing right here, and obviously in the middle of nowhere above the tree line, there's no cell phones. That's a non-starter. The only thing we had was amateur radio. I wish I had the HT in the picture there. You can kind of see the antenna there, kind of strapped to my shoulder. Actually, it was this HT right here. I don't know if you can see me in the corner. And so with that, I was able to, using digital modes, data modes, I was able to send my wife email. I was in touch with over SMS, so we could send messages to my daughter. In fact, my ex-YL was able to make this trip with me one year, only for the sole purpose that she could actually text our daughter using her phone, which would ultimately operate through the amateur radio. And so we were in constant communication with our daughter the whole time, because she didn't want to be out of touch for a week while we were in the high country in the Sierra Nevada. So that's just why this picture is here. In fact, I have another picture at the end of this. This is me in the Czech Republic, in the Old Town Square in Prague. And everything I just said about the High Sierras is also available in Prague. I actually sent a SMS message using this exact radio to the wife from the Czech Republic. So that's kind of why I put this picture here. So, we've got these global data networks out there. This is APRS, Advanced Packet Reporting System Service. It's a global network, it bridges to the internet in multiple points, and I think it's really underutilized. So APRS packet radio is a really popular mode. It's kind of like the data side of your radio. Everyone it'd be like buying a cell phone and only using it for voice and not texting. Well, most radios have APRS texting built in, and a lot of people don't use it. So I think that's something we can promote and evangelize, data modes. Because I'll be honest, when was the last time you actually saw a kid pick up a phone and put it up to their ear and actually talk to someone? I mean, people will look at them like they're on fire. No one does that, right? Everyone's texting, doing instant messaging. It's more of a rich media. It's less intrusive. It's non-interruptive. So I think to make amateur radio more relevant in the information age, we've really got to get kids involved. We really got to make it work with their phone and make it work like how they would expect to do communications. So amateur radio. So hey, this is the YouTube channel, youtube.com/@ KM6LYW. It's not, you know, the emphasis, of course, is on data modes and sending information back and forth. But we got a lot of cool hacks, stuff that I learned from you guys, like, you know, how to power your radio with a USB battery. I can actually key up and transmit with the newer power delivery USB batteries. So we're doing all kinds of stuff. We're playing with satellites. We're looking at where we can send messages through the International Space Station. I was playing with weather satellites for a little while here. And, you know, I kind of learn along with you guys, and then you guys will correct all my mistakes in the notes. So this is the YouTube channel, just a lot of fun. I try and put a couple of videos out, well, maybe 3 videos a month if I can. It's just tons of fun. YouTube.com/@KM6LYW. So one of the reasons I think we're here is that DigiPi thing we talk about. And I give this out to patrons of the channel. And of course, if, you know, John or Kevin, you know, if you want to give this out, that's cool. But just, you know, the chain of support's through you guys, right? But so if you want to help out with the channel, I will get you a copy of the DigiPi, and I will help you get it all hooked up to your radio and operational. So this is the DigiPi web interface over here on the left. Like I said, DigiPi is an SD card image that you download from digipi.org, and you plug it into a Raspberry Pi, which is a small system-on-a-chip computer. You can see it, a bunch of examples here on the slide. And then you hook that up to your radio. Like over here on the right, you see an ICOM 705, and it's just hooked up using a USB cable. It's really that simple. You turn it on, fill out a web form, it's your call sign, you know, where you're at, GPS coordinates, that kind of stuff, and then it just works. So right now, in most of these examples, you're seeing it doing APRS packet operations, but it will do so much more than APRS. It'll actually run FT8 or JSA call or FLDigi. Those applications actually display on your phone. So DigiPi doesn't have like a traditional screen and keyboard, right? Because everyone has a screen and keyboard in their pocket already, right? So it doesn't really need it. So all you need is, if you have a phone or a Wi-Fi device, basically a web browser, I don't know if you guys can see that, you can operate DigiPi. So this is your screen and your keyboard. It's your phone, or it could be your tablet. If you wanted to go that route, I've actually got a DigiPi up and running here. Well, I'll show you how it works here in a bit. But these are some screenshots. So DigiPi provides all of these data modes for your amateur radio and makes them accessible via your phone or Wi-Fi device or tablet or anything with a web browser. So you can see how that works here. So these are all the different data modes we can use on DigiPi. This is some more examples here. We've actually got a bulletin board system in there. If you want to turn on AX.25 networking, it'll become a NetROM node. You guys probably, I imagine you guys have a pretty good node network down there. This is where you can hop from node to node, communicate over the horizon using AX.25. The bulletin board actually has I actually put some video games on there. So you want to play Zork or Hitchhiker's Guide to the Galaxy, those are on there. So you can actually play video games over the radio using the bulletin board on the DigiPi. It's totally useless, waste of bandwidth, but the important thing is we're demonstrating that we could run any command to a DigiPi. That could be anything, you know, in a disastrous water. You know, how are we communicating? That kind of stuff. So it's a really good example of how we could implement emergency services using a node or AX.25 network. Of course, you know, no infrastructure is really needed for this, or if there is infrastructure, like a packet repeater, it would be solar powered on a mountain somewhere. So this is something that could never possibly go down. So yeah, the bulletin board stuff's been kind of fun. You can see there's a little screen on here. I wrote the software called DireWatch. So for APRS packet radio, it'll show you the information about the stations that are flying by. In the bottom right, you see a weather station here. Actually, that station's up in the mountains, the first picture I just showed you. So it'll do, like I say, it'll do every mode you can think of in data mode. So this is going to be PSK31. We mentioned APRS. It'll do slow scan television, which is pretty cool. We see that in the bottom left here. In the upper right corner, I'm actually doing a CW contact here using FLDigi. It's displaying on my tablet, running on the DigiPi, and operating the radio. So that's what these 3 devices here are in the upper right. But I was able to make a CW contact just with my tablet and DigiPi and that ICOM 7300 there. Because I'm not capable of decoding CW on my own, but DigiPi can do it, and it can encode CW, and you can set the words, the transmit rate, things like that, on using FLDigi on DigiPi. So it's really a collection of different applications that can talk to your radio, and there's no command line. You don't need to be a Linux guru. If you have to open a command line and like edit files and stuff, I've failed you. This is not what it's about. DigiPi is really kind of an appliance. In fact, it's read-only. So when you turn on DigiPi and operate it, and when you're done, you can just turn it off or yank the cable out. You can do that. If you can sync it out to SD card if you want, but that way, when you're on the summit or when you're on the parks and you're using a Raspberry Pi, this is literally a $15 computer. This Raspberry Pi. In fact, this is the one I recommend. $15 computer and maybe a $12 screen. I don't know if you can see me in the corner here. And you're ready to operate. And in this case, I've got a USB cable hooked up to an ICOM705. So I don't know, what's the cost of a USB cable? That's it. Alternatively, if you've got a dual band rig, like a Yaesu FTM 500, or maybe just an HT, we've got these other devices here. I don't know if I can highlight them. Like in the top, can you guys see my cursor? I don't know. Maybe my little hand. I don't know if you can see that or not. We've got some hardware that supports connecting your dual band system. So all you really need is audio in, audio out, ground, and push to talk, those 4 wires. If you can get those from your radio and into this, what's called a digital radio adapter, there's hardware manufacturers that are out there that are actually making hardware that support DigiPi software, right? Usually it's the other way around. Someone makes some hardware and then hopes everyone writes software for it. So no, we've got Masters Communications here in the up top. They've got a DRA Pi 0. It just uses a simple, I don't have an example here, but there's like a DIN6 PS2 connector that you can just hook right up to your radio. This works with DigiRig. This works with the new AIOC cable, so you can actually have your Baofeng radio like this. This is a great radio. I'm not suggesting everyone get Baofengs, but to hook this up to DigiPi, all you really need is an AIOC device, and this makes your Baofeng USB. You just put a USB cable into this, and now you plug your Baofeng into your DigiPi, plug your DigiPi into your radio, and you got all of these digital modes on a $35 radio, maybe a $30 USB interface, a $15 Raspberry Pi, and that's it. So for parks and Summit on the Air, you want to take this backpacking, which is what I do. This is really the way to go. And if we're talking about a Raspberry Pi Zero like this one, we're talking about less than 200 milliamps. So this is something that's solar powered, to something you can throw in a backpack. So DigiPi, every data mode there is available to you using your phone, Wi-Fi tablet, or web browser. I don't know if I went through all this. I have a bunch of other software, but I think that most people are interested in the DigiPi stuff. So we can actually do a demonstration if you guys just want to see how it works real quick. So this is my desktop. This is an actual DigiPi web interface. We've got a DigiPi, just gonna make myself bigger here. DigiPi in the upper right-hand corner, connected to the ICOM 705, and it is in APRS, TNC, and iGate mode. So these are the different services we can run. So it's kind of like an appliance. Think of it as an appliance, not a computer. There's no desktop. There's no clock or web browser. It's just an appliance. It runs one application at a time, and it does it really well. So I'm actually, I think I'm on the wrong frequency. This is on a WinLink frequency. So this is APRS mode. And as these packets come in, you'll see that the DigiPi is actually changing. The screen's doing cool stuff. Of course, now that I mentioned, I don't know packets are going to come in. So on the bottom, you're going to see an APRS packet come in, and then the DigiPi will decode that packet and display the nature of the packet there. And we've got some green lights and red lights for transmit and receive. It'll do Bluetooth. So this is a KISS TNC. I don't know how technical you guys are, but if you got something like APRS Droid or Radio Mail or APRS.FI apps, they will connect to the DigiPi over Bluetooth. And then you can use those apps with DigiPi and do all your SMS texting and email. So this is DigiPi doing APRS stuff. A lot of people think APRS is just about tracking and position reporting and watching someone go back and forth to work every day, right, with the radio. It's really not. APRS is really the texting side of your radio, but we did ourselves a disservice because it's really hard to text on a tiny little radio. So how do you, it's hard to do the 10-key texting on here. A lot of APRS-enabled radios will let you do messaging, but it's so hard to type on there. It's just not feasible. So what we did is came up with something called APRS Web Chat. This is loaded onto the DigiPi, and when we load this, you can see we have a messaging interface for APRS. So I can send a message to like WXBot. There's internet virtual radios out there that you can talk to. You can harass them, and you can give it like your zip code. And we're going to send a message over APRS to a station called WXBot. Now this is all over RF, okay? And there goes the message. You see my radio is transmitting. It's getting responses. You see my call sign. We're watching the screen there. There's a little thumbs up here next to my message indicating that WXBot received it, and we got the acknowledgement. Just a little smaller. And he responded. He's saying, I am 5 miles east of Auburn, California. Today is going to be sunny with the high of 66. I'm not bragging. I just happen to live in California. Sorry, I know it's freezing there. so high of 66. So we just sent a text message, radio APRS text message to another virtual radio. And there's lots of these radios on the internet that you can talk to and get information. In fact, one of them is called ISS. So when is the International Space Station going to rise? So I'll send a message to ISS, my path, and I can just say next. And we'll send that, and I can get my acquisition of signal time. The reason the ISS is kind of cool is because we can actually send SMS and email through the International Space Station. There's an APRS packet digipeater on the Columbia module of the space station. It works just like any other packet radio digipeater here terrestrially, so I can send SMS messages one way through the ISS. You're not going to get them back like we're doing here. But at least I can get email and SMS messages out. So even if there's no APRS infrastructure in your area, I believe there is, you can still use the International Space Station 4 times a day. Usually I get 2 solid passes in the morning and a couple of more solid passes at night. So, and you can set that, you can do that with this too. You just sent your DigiPass to ARISS. So, so Amateur Radio International Space Station. It would be the DigiPath if you want to send packets out like I just did here. Now the ISS station isn't responding. That's interesting. So this will resend messages. Yeah, it's doing that right now. And it'll get a response once it comes back. Now I can send a beacon too, and you have to send a beacon now and then just so the system knows where you are, so it knows which radio towers to light up with your responses or with replies to radios. Now, Kevin or John, I think you guys had a Kenwood there. I was going to send you guys a message to your radio using my radio. What was the call sign I should use, guys?
So it was N7UWX-9, right, Tyler? Yep. N7UWX-9. Have you beaconed? Yeah. Okay. All right, so Tyler has his radio there. It's listening to an APRS frequency, and here in America, that's 144.39. And his system's logged into the network because he just sent a beacon, and I sent a beacon as well. So I'm going to send him an APRS text message, N7 Uniform Whiskey X-Ray, if I got that right, -9. Sent via my radio. And I'm going to say send. That's going to N7UWX-9. Now, if Tyler's in range of a digipeater and he's registered in the system and his beacon made it out, he will get that text on his, I think you said that was a Kenwood D74. You'll get that text there on via APRS. And what's more is he can reply via his radio. And his radio will go through a digipeater radio system out there, and somewhere it'll hit an iGate, which is a radio that's listening, and it'll forward that to the internet. So the lion's share of that message, the center point is all done via the internet, if necessary. Obviously, we can't do line of sight between myself and Tyler. And then the other endpoint will all be over RF. So the endpoints are 100% radio frequency using APRS packet infrastructure, and then the center of the journey will tunnel using the internet if it's necessary. So I don't have a thumbs up from you here, Tyler, so I'm guessing your radio didn't get it, or I didn't get the acknowledgement transmission from your unit. Do you see anything there? He didn't get it. We're also inside a conference center in the guts of a building, so it may be tough. And
yeah, so this is 2 meters, yeah.
just so you're aware, I think on the ISS, they run theirs on a different frequency than 144.39, right? That may have been the reason.
Well, I'm on 14439 here, which is the global terrestrial APRS frequency here in America. It's 144.8 in Europe. But the ISS, you're right, that's 145.825. 145.825, that's space frequency in the 2-meter band plan for satellites. So yeah, I'm not using the ISS at all here, where I was using a wide one path. I can send you a second message. So this is 2 meters, right? So it's not gonna work really well indoors. I mean, I'm using a huge antenna on my roof here. So I'm getting out, I live in the mountains. So I did just get a message from WC7WSU-5. I got hello from Utah, DCC. So I did get that message. And then of course I can reply to that. So we got it one way, reply to your message. So we're kind of like half duplex. That's better than nothing. So you might not be receiving, but I definitely got you. I got hello from Utah, DCC. So thank you. So this worked. We actually got demos never work when I present these to clubs. So we're working at least halfway, half duplex. Nope, I got the ACK packet. And then we got one that says got it. All right, so it's working. How about that? Yay. KC7WSU, thank you. Thank you very much.
He did get it on his iPhone, or you got it on your radio, right? Yeah, that is some cool buggy whip stuff right there. 1920 stuff. I don't think Craig can do that.
So I'm gonna say super sweet, thanks for the demo. You know, it's like I go on and on about this, you know, for half an hour and then it doesn't work or something. So yeah, this is working fine. So yeah, I'm getting acknowledgement packets. That's what the little thumbs down, thumbs up thing is. So KC7WSU-5, you know, your radio is going to send me the ACK packet, so I know you got it. So it's and we got the N7UWX-14. This is nice. It works. Spelled with an E. Super cool. Thanks for the message. I'll send that out. So this is all on RF on my side. The power could be out here. Hey, I'm in California. The power goes out all the time. But I never lose access to email or SMS. And of course, I can always send messages to other radios. So that is APRS packet radio. Thanks for the demo, guys. I appreciate it. Super fun. So that's just the APRS packet radio stuff. There's so many other modes, you know, we could talk about. I'm not going to go into all of them, obviously, but like FT8, you know, a lot of people are really into this. I'm going to put this into FT8 mode. Switch over to my HF antenna, and I clicked on this little switch here, and then you'll notice this will turn green here. That means FT8 is running, so I'm going to click on WSJTX here. And it's going to connect, and then I'm going to unzoom it. I got that zoomed in for you guys. And there is WSJTX running in my web browser. Actually, it's running on DigiPi, but it's displaying in my web browser, but who cares, right? And this works over Wi-Fi, so this could, I could just as easily be in the family room, in my easy chair next to the XYL, you know, displaying this on my tablet or phone, and she thinks we're just having good quality time in the living room, but what's really happening is I'm actually operating FT8, right? She'll never know, and I'll never tell. So actually, I can display it here on my, so here's FT8, should be popping up on my tablet. In fact, I can go out on the porch, on the patio. This is on the right. This works in offline mode too. It's actually in hotspot mode. So if you're not at home, this will actually turn into a hotspot. That's what mode this was in. And so you don't need a Wi-Fi router, I guess is what I'm saying. Make sure I'm connected. Connect to my home Wi-Fi. So yeah, like in an emergency, when the power goes out, you don't have a Wi-Fi router. So suddenly, you know, you get your phone out and it comes up as a hotspot. And then you can connect to it that way using a numeric IP address. All right, I'm gonna go to, this is a lot of demonstration stuff here. All right, so let's go to WSJTX. And we can see WSJTX running on my tablet. And so this is just, it's actually running on DigiPi. Let me switch the frequency over here. It's probably a lot to ask for one of you guys to have an actual HF rig there. So I don't know if we can make an FT8 contact. I don't know, you guys are so sophisticated. You guys probably have a little HF rig. So yeah, actually 20 meters is really jamming here today. I think you can see it here. The stations are rolling in here. I don't know, I can make a contact. I got K0 something. I'm gonna enable the transmitter. And we are transmitting on FT8. It's really that simple. So again, I've done all this without doing any Linux command lines. I didn't need to know how Linux works or Raspberry Pis. All I did was insert this into a Raspberry Pi. I'll let FT8 run. There is a link here called Initialize when you first get it, and you can enter your call sign. Probably zoom this in a bit. You enter your call sign, your WinLink password if you have one, your UPS password, grid square, latitude, longitude, and you can select your screen type. We got 3 different screens. We got big, little, and medium. And then you can select your radio interface here. So we've got like a USB connected radio. If I select that, I enter my rig number. It supports all of these rigs, all of these Yaesus, Kenwoods, ICOMs, anything with a USB port, it supports magically with a USB cable. Or if you don't have an expensive radio like that, you can use an AIOC cable. That's this little red thing that would enable your Baofeng. You just select that, and then you click Initialize, and then it just starts working. It'll actually do radio detection now. This is like a development release of DigiPi, so the current release doesn't have all this cool stuff to show me what radios are physically connected, so I know which device files to use. But this is the initialization page. So configuration is drop dead easy. No command line, no editing files. Let's see how we're doing on FT8. Hey, look at that. I have a contact. That never works during a demonstration either. Boy, I sent him a +20. He sent me a +5, and I'm at 10 watts on this radio. So that's not too bad. What is that? The KO6GQH. No idea where he is. All right, so I'm gonna say okay to that. So that's FT8. We did an FT8 demo. I guess if we're gonna do one other demo, that would be WinLink. So this would be email. I just click on the PAT WinLink email client. It automatically starts up AX.25 networking. I do need to pick a frequency. Let's click on PAT email. So this is your email box. So everyone knows how email works. So you got your inbox, your outbox, sent, archive. Here's an email I received. We have a WinLink net. Receive this over the radio. And there's probably WinLink email servers in your area. So I can just say action, let's see, action connect. I'm just gonna check my email. I probably don't have any in there. I can get a list of email servers. If I click update cache, it'll show me the short list. And let's see, we don't wanna use RDOP, we wanna use packet. So RDOP would be for like HF modes, and you can connect to other email servers somewhere else in the world. Like I can reach Australia email servers, no problem, no middleman in there. And then I'm gonna do NB6S-8, so this is gonna be over 2 meters, so I'm gonna switch antennas. You notice the radio automatically changed frequencies to 145.730. Make sure we're in FM data mode. This one always trips me out, it's still in USB mode. FM data mode. 145.730. We don't necessarily have to wait for a clear channel on packet radio because we can all share, because we're just sending short bursts of data and they're all interleaved. It's one big collision domain. It kind of works like a TCP IP. So let's connect to NB6S-8. He's 9 kilometers from me. I'm gonna say connect here. Transmit. Of course, as far as I know, he might be down. Sun just came up. I don't know if he's on solar panel or not. Yeah, there it is. We can see NB6S-8 on the display. We are exchanging data now. And if you look at the bottom of this, you can see connected to NB6S-8, dual mode gateway, director via MTVNOD, which is a digipeater for packet radio on this frequency. It checked my email and then said disconnected. I know that's not very exciting, but I didn't have any email. But we can actually compose email here. I can say to some email address at some domain, or I can put in a call sign, KM6LYW, and it will go to both. So I'm not going to give away my email address here on YouTube. So I say, hey, this is an email, and this is the body. Post that. Action. Now it's in my outbox, so I'm going to say connect again. Here it is in my outbox. And it's transmitting and receiving. I don't know if you can hear this. There you go. It's sent my email. Actually, it's transmitting it right now. That was just the handshake. So hopefully you guys could hear that. That's what actual packet radio sounds like on 2-meter frequency. So we're sending email. And transmitting, and this goes at the speed of smell, right? This isn't like internet speeds at all. We got a hello from Utah DCC. somebody's ahead of me here. So someone just sent me, so AL0E, you guys are great straight men. No message body, so we got the subject. So I did receive your WinLink email, so AL0E, thank you for that. We obviously have some character WinLink experts in the room, so yeah, thanks for helping me with this demonstration. So yeah, sent and receive email, no problem. All over 2 meters, all over the radio here. You know, one thing I didn't demonstrate here was, let me get my phone here. I can go back to, let's go back to APRS real quick. And that was I can demonstrate sending an SMS message. This is cool. This is what the kids are into, right? So I got my phone there, and turn off Pat. We're gonna go back to APRS web chat. Now there's a virtual call sign out there called SMS, which is really cool. A guy named Michael Phelps makes this, not the swimmer, but super guru radio guy. So I'm gonna send a message to SMS. Now this could be an ampersand and then some phone number, and then message text, okay? But I'm not gonna give out my phone number here, but so you can set up an alias also. So I set up an alias for myself, CL, and say, hey, this is an SMS to your phone, and I'm gonna send that. And we're on the wrong frequency, so that sucks. All right, get back on APRS. All right, so I sent a message to a radio call sign called SMS. We're back on APRS, right? And the message tag was an ampersand CL, and hey, this is an SMS to your phone. And if it goes through, we will get a little thumbs up here. That'll be an acknowledgement from the SMS radio service. I was on the wrong frequency on the first send, so it'll retry. And ideally, we are going to see an SMS message pop up here on the phone once it goes through. And what's cool is I can actually reply too, so that's kind of fun. All right, so I don't know how, I haven't been watching the transmitter. It takes about 30 seconds for the second retransmit to happen. And if it gets an ACK, you know, obviously it'll stop transmitting. So it's generally a connected protocol with this. It's not like UDP where you send and pray. This is actual sending a message, waiting for the acknowledgement. There's message numbers. The APRS uses a subset of the AX.25 networking protocol, so it's really simplified. And we'll see here, hey, we got a message on our phone. You guys see that? Miraculously, it worked. So here's the message, and I can actually do a reply. Hopefully you guys can see this. I don't know if I can do this one-handed. And I can do a reply via SMS. Of course, this is using a cell phone and unreliable DMS, that's not right. Unreliable networks. My wife is texting, of course. Okay, I can do that. And I'm gonna send that. Actually, that went via email, that's interesting. I should have sent that via SMS. There it is. Hey, this is SMS to your phone. This is a reply. And then I'll put a bunch of exclamation points. Hopefully you guys can see that. All right, send it. And let's go back to the SMS radio call sign. And sure enough, here are the replies I just sent myself. Again, the web browser is completely on RF, no internet locally at all. And now in the back end, somewhere out there, there's radios connected to the internet that are making this work. So actually we're getting APRS questions, but you guys are awesome. I can't believe how connected you guys are. You guys probably teach this thing. Hey, does DigiPi work with the rim light from Repeater Builder from the DCC? I don't know. KI0E, I'm assuming you're in the crowd. I don't know what a rim light from Repeater Builder is. I know what Repeater Builder is, but I don't think I could tell you. I don't know. So it works with all of the things that I showed you on the initialize page, and probably a lot of clones. So that's going to be the, let me see if I can zoom this in so you can see what's going on. That's going to be an FE, it's going to use GPIO pins if you want to twist a transistor together and make push-to-talk work. It's going to use a USB connected radio. It's going to use the AIOC, which is a C-Media 108 audio chip that has some GPIO pin switches on it. It will use that. That's this little red thing on the Baofeng. It's going to use a DigiRig mobile. DigiRig devices are really cool. It turns any radio into a USB connected radio. It's going to use a DRA Pi Zero hat. This is from Masters Communications, really popular, great guy. It'll use something called the DigiPi hat. Again, they're making hardware in support of DigiPi, which is fantastic. DigiPi hat is another thing. It'll use an audio injector. So these are the different radio interfaces. So to answer your question, I don't know. If the radio interface is similar to one of the ones I just described, then yes, I'm going to say it works. So great question from KI0E. I can't believe we're taking questions over APRS. You guys are geeks. What a bunch of nerds. I love it. This has got to be one of the best clubs I've presented to. So, with that, are there any questions? I've done a whole bunch of cool stuff here. I'm going to close all this stuff down. Any questions for me, guys? I've been using up your time.
Is there anybody
here.
in the audience questions? Yeah. Okay, I'm going.
We got hands up, Craig. I don't know if you
Oh,
can hear.
good.
I'll relay
Maybe
if
I
we
don't.
need to.
It's hard for me to hear, so
Kevin will
I'm
have
looking
to
at you
relay
guys.
for you.
So maybe you could repeat the question for me. So go ahead and call on people, please.
Okay, the question I had, when you're running the JS8 software, who's providing the time standard so you can get in link with everybody on the network? Is it the DigiPi? Is it the, who's?
Great.
Where are you getting your
Great
time
question. Yes, so system, you have to know exactly what time it is to do frame-based or time-based packet modes, which is FT8, JS8 call. So yes, there is a GPS actually built into the ICOM 705. You can see the little icon here. Is it flashing? If it's solid, that means it's working. And if it detects that GPS, it will get time from the satellites. In fact, if I click on GPS down here, you will see the GPS date, time. It actually has your grid square in here too, down at the bottom, which I thought was totally kind of a cool feature. So yeah, it's getting time from the GPS to answer your question. Now, if you were to plug in a GPS dongle, it would get time from that. In fact, on the initialize page, you'll notice there is a GPS device setting here where you can set your GPS device, and it'll get time from that. Of course, if you're on the internet, it'll get the time from network time servers. Great question. And you can also see if it's working. These are some new features I just added, so I'm showing them off. At the very bottom of the system information page, you can actually see the system time. And it'll constantly update. Great question. Yeah, you got to have time or this is useless.
Okay.
Got another question. We're getting the mic to him.
Great.
Will your software work with the Libre computers? The one that I'm familiar with is the Lamparter. It's a sort of a Raspberry Pi clone, but not quite.
Another great question. The answer is no. This works with Raspberry Pi,
I'll finish it for you.
the Banana Pi, the Libre unit I think you just described. No, it's not going to work with those. That's because this boots, the actual boot sector, boot contents is firmware for the Raspberry Pi and a very specific Linux kernel that works with Pi. So this will work on the Pi 02 wireless, which is what I really recommend. Everything runs perfectly on this, and it'll run on the Pi 3, the Pi 4, the Pi 5. In fact, this is a Pi 5 over here. I don't even recommend a Pi 5. It's just overkill. I'd get a $15 Pi 02 wireless, and it'll run just as well, unless maybe you're doing like deep decodes for JS8 or FT8, and maybe get a bigger one, because the Pi 5 has like a fan on it. I don't know. I don't like fans. Good question. No, Raspberry Pi branded system on a chip only.
Other questions?
I think one thing that I noticed on this, maybe you speak to it, is that the SD card is locked when you're using it, and that kind of prevents that issue where you get a lot of SD card crashes, especially in emergency communications. It's kind of SD card failure is but I noticed you actually lock the card while it's being used.
Yeah, I don't know if there's a question in there, but yeah, that's exactly why this is like this. So yeah, the SD card's actually mounted read only when you turn this on. So you can play with it all you want, and then when you turn it off and turn it back on, it's exactly like when you turned it on the last time, because it's, unless you press save configuration, in which case it'll save like your application tweaks or your logs, like your FT8 logs. Those will vaporize because they're in RAM disks when you turn DigiPi off, unless you press save configuration, in which case it commits any changes that you made to the SD card, and those changes will be there on next boot. So yeah, that's a great question. It is in appliance mode. You know how it is with computers these days. You get all this stuff working at home and everything's great, and you pack your backpack and you go to the summit and you turn everything on and it's just that nothing works. DigiPi, that's not the case. It's read only. You can't possibly screw it up between your house and the summit. Yep.
Someone said, watch me. They can mess it up.
That's not a dare. Because that happens to me all the time, yeah.
Got a question over here.
Here we go.
Craig, I think you sold a bunch of DigiPis today, and some Pi Zeros and some Pi 3s and some Pi 4s.
Craig, what is
I hope I sold you on the idea of data modes, okay? This doesn't have to be hard. Let's make it easy.
This is a Swiss Army knife for hams.
What power consumption, say we're out remote, what power consumption, 12 volts?
Great question. So for the Raspberry Pi Zero, I've measured this like at most, this is the 02 wireless, at 250 milliamps. So what is that at 5 volts? You know, that's like 2.5 watts. That's the power consumption for this guy. You know, the screen's going to add a little more. I've killed things like certain subsystems inside these that just aren't necessary, like HDMI and stuff. You know, but the lion's share, you know, this is going to pull 2 amps, right? That'll be most of your power. But yeah, it's negligible, honestly. The Raspberry Pi current draw. Now, if you could do Raspberry Pi 5, of course, it's going to be a lot more than that. That's why I say it's overkill. So yeah, 250 milliamps, it's nothing.
So you don't see any lag or any issues with the Pi Zero?
I don't. A lot of people fight me on this too. Say, well, I'm going to get a Pi 5, you know, because bigger, better, faster. But, you know, it's also more power hungry. It's larger. It's heavy. It's
costs a lot more.
It costs a lot more, right? It's $80 for a Pi 5. It's $15. And the reason we can get away with that is because we run one program at a time. We're not running a whole desktop with web browsers and clocks and things. This is actually 512 megabytes. You can't run a lot of these apps like FTA or FLDigi will not fit in 512 megabytes if you have a full-blown desktop alongside of it. But we can with DigiPi because all we're doing is running FLDigi, for example, which I just started here. And it barely fits in 512 megs. So this is my budget, memory-wise, 512 megabytes. We don't go over that. We go over to FLDigi.
So while you're bringing that up,
go ahead.
While you're bringing that up, if your unit there is read-only, do I have to do the configuration every time you power it up? Or by clicking on Save Configuration after you initialize it, put your call sign in and all the passwords, does that stay? Or do you have to re-input all that information?
Ideally, we don't re-input the information. So the first thing we do is initialize. I think we covered that. This is and this populates a lot of the applications. But like when you go into WSJTX, you have to, select your rig and stuff. The point of DigiPi is so you don't have to do any of this on the command line. So once you got DigiPi set up just how you like, and you got, your colors or whatever and all that, you press Save Configuration down here, and it will commit that to SD card. Now, at this point, it's read-write, and so you need to shut down gracefully so you don't corrupt the file system. And then the next time you reboot, it'll come back read-only mode, but with your old the previous configuration that you just saved. Yeah, good question.
Anybody got a Pi I can take home today?
We're actually giving one away.
Oh, yeah.
I was trying to pitch it as like our grand prize, but then he's like, oh, it's a $12 Pi. And so that won't be our grand prize today.
Any other last questions?
Just ask him about the log.
How do you pull the log files? So say you hit save configuration, how do you access that log file? Do you have to pull the SD card?
Are you talking like the FT8 log?
So if you log something in FT8, how do you get that off the Pi?
So the logs are written to a RAM disk until you press save configs, and then they commit to the SD card. Now, I use a Linux desktop, so I'm probably gonna get this wrong. If you have Windows, you can use something called FileZilla and use SFTP or SCP to copy files off of the Raspberry Pi. The documentation for DigiPi, in fact, if you go out to digipi.org, we have some information on that. So yeah, you can download your logs from DigiPi once you bring it home using a file transfer utility. I mean, I use SCP on Linux, but I don't know if that helps. Yeah, that's a good question. And make sure you do save configs after you make all your contacts, because if you unplug DigiPi and you haven't pressed save configs, they're gone.
Anybody POTA out here? Imagine how easy POTA would be. Just leave all your gear in your car and just go out on the picnic bench with your tablet. Make your contacts.
All over Wi-Fi.
Yeah.
Yeah, it becomes a hotspot, so you don't even need a Wi-Fi router. When you turn DigiPi on and it doesn't connect to your home network, it actually comes up as a hotspot called DigiPi. So you turn Wi-Fi on your phone, you go to network, connect to the DigiPi hotspot. The initial password is ABCDEFGHIJ. There you go. I just gave you that.
All the secrets right here at Utah DCC.
Yeah.
Got another question?
I have a question. Call sign's KJ7LAX. But anyway, do you have a hardware list of like the part number for the screen or the Pi Zero? To get everything that we need, is there a list somewhere?
Yes, great question. And in fact, I'm on that webpage right now. It's digipi.org. Should be everything you need. And here you will find a shopping list. And of course, it's really, you can tailor this however you want. The only real constraint, it has to be a Raspberry branded Pi. It has to be Raspberry Pi. But again, that's between $15 to $80, depending on how, what your budget is.
Craig,
and you can get the little, go ahead.
No, go ahead.
You can get the little screen here. I've got links to all that stuff. So if you want to get the Pi Zero, you can get it from multiple places. Where can you get the little screens? Like you can get the tiny little screen on Amazon. I think it's $16. You actually have to buy two. It's $23. So get two.
The screen is 23. The glasses are 180.
Or AliExpress. If we would have been smart and planned ahead, Craig, we could have had a table full of Raspberry Pis out back. We'd have sold a fortune, and instead of $12 charged 15, they would have bought them, right?
Yeah, they're worth more than the sum of their parts. So yeah, you got to go out and buy all these little parts, then smash them together, and then get the DigiPi, download the SD card image, burn it to SD, put it in, turn it on, and then look for the DigiPi hotspot on your phone, and you're on your way.
Yeah, so it's so low cost when you look at MCOM, right? You can just have two. Two is one is none. What I did with mine is I have my file that's save config, and I actually just have two SD cards. And I keep one stashed away, so if I do happen to somehow really mess it up, I can just pop out the SD card, put another one, and my config is there and ready to go.
All good hams would have two SD cards for this. It's not hard to corrupt an SD card with the Pi. Anyway.
Any other?
We got time for one more.
One more question. Here we go.
So I get the feeling that I already have the answer to this, but with the FL Digi implementation, is there a way to use FL message with it? And if not, is that planned for a future release?
Uh-oh.
We ran out of quarters.
There we are.
Oh, there we go.
We're back. We lost you for a second.
FL message, right?
Hey, how long was I vaporized here?
About 10 seconds.
We put some quarters in, you're good. FL message on DigiPi.
Can you hear us?
Yeah, I got you now.
Question.
Yeah, I can see and hear you. Can you hear me okay?
Yep. Question was about message on FL Digi, right?
Sorry, FL message.
Oh, FL message.
Oh, FL message. No, FL message and FL amp aren't on there. People keep asking for that. I need to research that.
that's something that I will add. So that was FL Digi you just saw. It does Olivia, Contessa, PSK packet. It'll do all the other ones. This is doing JS8 right now. Upper sideband. I'm just doing demonstrations here while we're doing questions. I'm sending out a heartbeat in JS8.
FL message is 520 megabytes. So I'm just kidding. I think FL message has to sit on top of FL.
So
Anything
yeah,
else?
our budget's 512 megs. So FL Digi pretty much burns all of that all by itself. So.
All right. Let's give Craig a round of applause for a fantastic presentation.
Thank you.
Craig, I've sat through lots of online presentations, and you keep it entertaining. You're great at it. So.
Wonderful. Thank you for having me. I appreciate it.
I was hoping you'd do a guitar riff on your way out. Yeah, see, we got hands.
My noise
We got hands up for guitar
won't
riffs.
hear the guitar. I've tried that. Yeah, no, sorry. Next time.
That's an extra.
Yeah, that's an extra. That costs
Yeah,
extra.
you got
on
to
the
pay
booking.
more for that. Sorry. Yeah.